All right, so let's go through what we should have done. Most of us struggled with this quiz, so let's try to figure out why and learn from our mistakes. Okay, so we're given this prompt right here, and so we're given a function, and they tell us it's the graph of f. So right here, it's the graph of f. That's something you got to keep in mind. It's got some linear pieces over here. It's got this area that's labeled A. It's got this region area here labeled B, and that's got this curve. Function's continuous from -4 to 4 inclusive. The graph's shown above, and it described this two line segments and portions of three parabolas. The graph has horizontal tangents at -1/2, x equals -1/2, x equals 1/2, x equals 5/2. So they're giving you exactly where these transition points are occurring. And then it is known that f of x is equal to this parabola here, but that's only between 1 and 4. And a mistake that a lot of you made, you try to use that in other places. You try to use that for region A when that's not region A from 1 to 4. That's the unlabeled region that's over here. And so that was a mistake from a good handful of you. The areas of region A and B are bounded by the graph of f, and the x-axis are 3 and 5 respectively. So that just means the order is clear. So A came first, and the 3 comes first. So that's going to be area A is 3. But you have to remember that's below the axis there, so it's going to end up being -3. And then B is going to be 5, and that's above. So that's going to be a +5. And then it says let G be the function defined by g of x is the definite integral from -4 to x of f of t dt. We want g of 0 and g of 4. So start with g of 0. So just by definition, g of 0 is going to be the definite integral from -4 to 0 of f of t dt. And what they're doing here is they're combining for you a couple different conceptual ways of understanding what the area bounded by a curve is, or what an integral represents, the area bounded by a curve. In this case, the net signed area. And so what you have to do is you have to do a little bit of geometry here, and you have to realize what they told you, and then do a little, God forbid, arithmetic. Okay. So from -4 to 0, so we're going to include all of this stuff here, which I went a little bit out of the lines. Excuse me, this is hard to control, I guess. And then this here. So what we're going to have to do is we're going to have to take the area above, which is the area bounded by that triangular region, and subtract 3 from it, the area bounded by A. Okay, so that's what we're going to be doing. So how do we find the area of a triangle? Half base times height. So the base here is from -4 to -1. That's just 3 units. Okay. So it's going to be 1/2 times 3 units times the height, which is also 3 units. And then again, we're going to subtract from that the area of A, which they told us was 3. So -3. Okay. And that's all you need to do. In fact, you could stop right there. And not continue. You don't have to simplify, because if you do simplify and you make a silly mistake, then they're going to penalize you for it. And they encourage students not to simplify. But for those of you who did simplify, this comes out to be 3/2, because that's 9/2 or 4.5, and 4.5 minus 3 is 1.5 or 3/2. Okay. Most of us got G of 0 okay, but some of you did you try to use circles for regions A and B, but those aren't circles, so you shouldn't have used that. Now, for G of 4, you need to, again, use the definition. You have the definite integral from -4 to 4 of f of t dt. And then, they like to do this. They like to layer questions in there, so you kind of have to, you have to use what you've already done. So you know that this is going to be the definite integral from -4 to 0 of f of t dt. Okay, we just found that, so you're going to use that value. And then it's going to be, if you look at the region up here, from 0 to 1, we have a different function than from 1 to 4. So we're going to further break that down into subintervals, and we're going to go from 0 to 1, f of t dt. and then from 1 to 4, f of d dt. And this is where they're, again, layering different concepts together. The integral from -4 to 0, we already found that to be 3/2. The integral from 0 to 1, well, the area is the area of B, and they told us that area of B was 5. So I want to make sure that you understand how to interpret that. And in fact, in the solution guide, they wanted to see that you broke this up into these two separate integrals here. That was a key part. It was one point of getting this, that you actually have an integral from 1 to 4 here, then not just do the whole thing from 0 to 4. And then plus, now from 1 to 4, they didn't give you the area. This is where they're using the next concept. They want you to actually evaluate this using skills that we learned in this class. And on that region, the parabola is negative x squared plus 5x minus 4 with respect to x. Okay, and so to evaluate that, I saw a handful of you not find an antiderivative. There were a handful of you that just plugged in 4 into that expression, plugged in 1. The fundamental theorem says you have to find an antiderivative and then plug in the endpoints and subtract. And so it's a silly mistake not to do that. But nonetheless, we get 3/2 plus 5 plus, find the antiderivative, so negative 1/3 x cubed plus 5/2 x squared minus 4x, and again evaluated from 1 to 4. Can't stop there. They don't take that as a sufficient place to stop. So you're going to have to plug in 4 and plug in 1 and subtract. So if I plug in 4, now again, you can just do this because that's the same thing. You don't actually have to work it out. 4 cubed is 64, but you don't have to do that. Plus 5/2 times 4 squared minus 4 times 4, and then minus, and then you plug in 1, you're going to get a negative 1/3 plus 5/2 minus 4. You could stop right there. That's the correct answer. Except make that 5/2 look a little bit more like 5/2. Try to be clear in your writing. If you do all the arithmetic and work it out, it becomes 11, but you don't have to work it out to get 11. That's sufficient right there. It's a 4-point question, 1 point for G of 0, and then G of 4 was 3 points to get this because there were a lot of things to do. And so you get a point for, I think they said a point for, I don't have it in front of me at the moment, but a point for writing the integral from 1 to 4, a point for finding the antiderivative. So you get a point for just working backwards from negative x squared plus 5x minus 4 to its antiderivative and antiderivative. And then one more point for the final answer. That doesn't mean having simplified it to 11. The step before here that I left, that is a correct answer, and that is sufficient. So by all means, stop there. You don't have to continue. All right, for B, they want us to find the absolute minimum of G on the closed interval -4, 4. What really bothered me was that some of you went and found the local or relative minimum justification or answer and justification on here when that wasn't what was asked. The word absolute is right there. You can't make that kind of mistake. That's a silly mistake. And maybe it's like conceptual one too, but it is silly not to read that carefully enough to understand what they're asking of you in this question. It's also one of closed intervals. So for all of us, it should ring, into our minds to use the closed interval method. Okay. The closed interval method, we've done it many times. You should understand it, and it shouldn't be that hard to work out. And if you go through the steps of the closed interval method, you can get a lot of the points for this one. I think this was a 3-point question, and it doesn't take a lot to start getting some points from that, okay? So what's the first step in the closed interval method? Well, we need to figure out the critical values, okay? So we need to figure out whether the derivative is 0 or undefined. And so we're trying to find minimum values of G. Let me put this down here. So that means I need to find G prime. And so they want to see this here. This is 1 point of the problem. You acknowledging that take the derivative of G, you get F. That's a fundamental theorem question. And the fundamental theorem is going to be on this test multiple times. It was already on in part A when we had to take an antiderivative and plug in the endpoints and subtract. It's going to be on this exam. It's the fundamental theorem. That's in the title. It's got to be there in multiple forms. So you get 1 point for just doing that part. You get 1 point for, I'm trying to remember now. I don't have it in front of me, but you had to set it equal to 0. I'm not sure that was a separate point from that. But anyways, point for the fundamental theorem. You got to set it equal to 0. So where does f equal 0? We're going to scroll all the way back up and take a look at the graph. Okay. To look at the graph, this is the graph of f. So where does f equal 0? It's all the points where the graph intersects the x-axis. So at -4, -1, 0, 1, and 4. So I'm going to go back down here. So this is true at -4, -1. I think I said 0, 1, and 4. If I made a mistake, I apologize. Now, they understand that they just look for you to acknowledge 2 places on this one. They gave you a point for these 2. My point values may be off, but I remember it said in part of the solution there, then you as the student putting the answer needs to acknowledge those 2. Why those 2? Well, let's go back up to the graph really quickly. At -1, we cannot have an absolute max there because, we cannot have an absolute minimum there because the derivative of g, f, is going from positive to negative. So that would be a candidate for an absolute max, but because there's going to be a local max there, but you cannot have an absolute minimum at a place where there's going to be a local maximum. So we can rule that one out, okay? 0, there's going to, the derivative goes from negative to positive, so there's a local minimum happening there, and it could be absolute. We don't know. We have to check. At 1, there's no change there. It's positive before, positive after, so there's no local extrema there, so we're not going to have an absolute max there. And 4 is an endpoint, so they're not really acknowledging that one. I'm not sure why they're leaving that one out of the mindset. So we only really need to check. We're supposed to plug in all the critical numbers into G and see which one's the biggest and which one's the smallest, but we can save ourselves some work and we can throw out looking at -1 and 1 because, again, at -1, there's going to be that can only be an absolute max because it's already local. It may or may not be. I don't know. I didn't test, but it certainly isn't going to be a minimum. So we can throw that one out. We don't have to look there. And at 1, there's no extrema happening there at all, so it can't be an absolute minimum. So we're going to throw that one out too. So I only need to look at -4, 0, and 4 and see what's going on with those. Okay, and we've done some of the work on this. We know G of 0. We do know G of 0. That's 3/2. I'm kind of going out of the order that I wanted to, but that's okay. G of -4, that's easy. That's the integral from -4 to -4 of f of t dt. And this is them testing your concept knowledge. Okay. Do you understand that, when the upper and lower limits are the same, that the value of the integral is 0? You should. Okay. And then the integral, G of 4. Oh, we already calculated G of 4, so that's something else that we can look at also. We already saw that was 11. Okay, so at this point, once you've done all of that, all you have to do is answer the question. Just answer the question. Just write a sentence. Okay, therefore, and you can even say by the closed interval method, but they didn't indicate whether they were going to penalize you if you didn't. Therefore, by the closed interval method, the minimum is 0. The minimum is not -4. It doesn't ask for where the minimum occurs. It asks for what is the minimum. It's the output. Now, it might be safer for you to put G of -4 equals 0. That way you've answered actually the where and the what question. And that would be a good habit to get into, just in case you're not paying close enough attention. You have both the where, it's at -4, and the what, 0. And in case you missed how they asked the question, you're going to be okay anyway. All right, let's get on to part C. It says find the intervals on which the graph of G is concave down. This is such a should be such an easy question for us. We've done so many examples like this. G is concave down, is CC down. And most of you understood this when G double prime is less than 0. Now, what is G double prime? We already know that G prime is equal to F. So G double prime is going to be equal to F prime. So I need to figure out when F prime is less than 0. What does it mean for F prime to be negative? That means that F has to be decreasing. And in their solution, they said specifically that you need to make a connection between the graph of F in your reasoning here. So you have to say that F is decreasing, okay, or the graph of G is going to be concave down where F is decreasing. If you don't have that connection there, you're not going to get that extra point. And I think this was only a 2-point question, a point for the intervals and a point for the reasoning behind it. So where is F decreasing? I got to scroll all the way back up here. Well, F is decreasing on, let's see, I'll use this blue here. So it's decreasing where it's going down, -2 to 3, but it's actually decreasing all the way down to here. Okay, so that's at 1/2. So -2 to -1/2, -1/2, not 1/2. That's an interval where it's decreasing. 1/2 to 1, that's an interval where it's decreasing. And then we said 5/2 to 4, that's another interval where the graph is decreasing. This graph is going down. That means the derivative of G is decreasing, which means that G is going to be concave downward. So at that point, you just got to write it up as a sentence, which I'm gonna let you do just to keep this video a little bit shorter. All right, let's take a look at the second question. So they give us a table of data, which is common. They want to see that you understand how to work with tables. The function f satisfies f of 0 is equal to 20. The first derivative of f satisfies the inequality. In other words, f prime is bounded between 0 and 7, inclusive. F prime could be 0, it could be 7, or any value in between. For all x in the interval from 0 to 6, selected values of f prime are shown in the table above. The function f has a continuous second derivative for all real numbers. And in part A, it says, use a midpoint Riemann sum with 3 subintervals of equal length indicated by the data to approximate the value of f of 6. This was at least a 3-point question. Again, I don't have the solution guide in front of me, but it's okay. We can just reason. There's a lot of things to do, and a lot of you only got 1 point for this because you did the midpoint sum. Most of you did the midpoint sum, Riemann sum correctly, but you didn't actually find f of 6, okay? And I'll show you why you didn't find f of 6. So we're going to use 3 subintervals of equal length, okay? So that's the first thing here. So how do I use 3 subintervals of equal length? Well, if they got to be equal length, then my delta x, I'm going to write over this area here, is going to be 6 minus 0 over 3, or they're all going to be 2 units long. So my first interval is going to go from 0 to 2, and then it's going to go from 2 to 4, and then it's going to go from 4 to 6. I'm going to need the midpoint on each subinterval. So the midpoint, there's not much to think about here. The midpoint from 0 to 2 is 1. The midpoint from the way I drew that kind of looks a little unbalanced, but the midpoint from 2 to 4 will be 3, and the midpoint from 4 to 6 will be 5. So to do my midpoints here, it's just the area of a rectangle. So what's the first rectangle? Well, it's got a base of 2. They all have a base of 2 because we said equal length, and the height's coming from the midpoint, so it's 2 times 3.5. What's the second one? Well, the second one, again, base of 2. The midpoint is 3, so the output there is 0.8. And then the last one, also width of 2, and then 5.8. Okay. And again, this is not the answer. What is it? I forget what this comes out to. That's 7 plus 1.6 plus 10, 11.6. So that's 12, 13.2. So it's 20.2 is that value there, but that's not the answer to the question. Okay. You're approximating f of 6. I haven't even talked about how to get f of 6 yet. I've just done the midpoint Riemann sums on this without even understanding where to get f of 6 from. Everybody should get that 1 point. The problem is a lot of you thought that was the answer to the question, and that's where you had your mistake. Okay, so let's think about the fundamental theorem here for a moment. I have f prime, and if I integrate f prime over a couple of values, notice they gave us f of 0 was 20. So I'm going to go from, and I need f of 6. So if I go from 0 to 6, according to the fundamental theorem, this has to be f of 6 minus f of 0. Well, I just approximated the integral part. That's our midpoint Riemann sum. So 20.2 is approximately equal to whatever f of 6 is minus whatever. Wait, they told us f of 0. That's 20. So f of 6 has to be approximately 20 plus 20.2 or 40.2. And that's where a lot of you went wrong. And it becomes costly because they only give you 1 point for the 1 point for using midpoint Riemann sums. And then the other point is the fundamental theorem and then the final answer. So that's where a lot of you are missing out on points that are easily gotten. Okay, you did the midpoint Riemann sums, great, but let's make the calculus connections. Midpoint Riemann sums comes up in the calculus test, but really you learn that in pre-cal. Where's the calculus here? It's in fundamental theorem. Again, fundamental theorem in this problem. Okay, all of us could have done that. Well, many of us could have done that a lot better. Most of us got this wrong. There were only a handful of you who saw that connection. And great for those of you who did. Those of you who didn't, all right, step it up now. All right, moving on to part B. It says determine whether the actual value of f of 6 could be 70 and explain your reasoning. If from this entire quiz, this is probably the most challenging question because it's a little bit cryptic and you're under time pressure and how am I going to figure this out? Well, it's okay. Luckily, I think it's only a 2-point question. But nonetheless, they tell us that f prime is bounded between 0 and 7. So that right there gives you a little bit of clue where to start looking. If you remember back in section 5.2, I talked about if my function here, I'll give it just a quick little recreation. This is my function f. I said that we can bound the integral from on that interval by the area of the rectangle produced with a height of the maximum value of the function, so that the integral from a to b of f of x dx was less than or equal to m times b minus a. All right, well, if we apply that here, so f prime is bounded by 7 in max. So if I look at the integral from a to b of, not from a to b, hold on, let me fix that, because we're on an interval from 0 to 6 here for f prime, then I know that that has to be less than or equal to, well, the rectangle form, the maximum is 7, the width of the interval is 6, so it has to be less than or equal to 42. Okay, but that's not the full analysis right here. Remember, this side over here is going to be f of 6 minus f of 0. That has to be less than or equal to 42. So f of 6, we know f of 0 is 20, but let me just do this. Let me add that f of 0 to both sides here. So f of 6 is going to be less than or equal to 42 plus 20, which over here is 62. So f of 6 cannot be bigger than 62. So no, the answer that f of 6 cannot be 70. Okay, that's how you answer that question. I admit that of all the questions, we never tackled anything as that directly like that. Indirectly, I showed you this property here, and you're supposed to make those connections. And in a time test, it's hard, it's challenging, but you don't have to answer 100% to get a 5. You don't have to answer 70% to get a 3. Okay, so get as many points as you can, and if you could have written something intelligible down here, something, maybe you get some partial credit. Leaving it blank gets you nothing. So don't leave it blank. Put something down. Try as long as it's not wasting time from other questions you could be more productive on. But give yourself a shot, okay? Now, if question B was the more challenging question, or maybe perhaps the most challenging question of the quiz, part C had to be the easiest. And there were people who left it blank. And there are plenty of people who got it wrong. Just some of you got it wrong for silly reasons, and some of you got it wrong for conceptual reasons. But how many times I've even said in this video, the fundamental theorem is important and it's going to show up. And that's all this question is. It's the fundamental theorem and subtraction. And it's really not that hard. I mean, seriously, you guys would look at this and think, how did I not get this if you didn't? How do I evaluate this with the fundamental theorem? I need an antiderivative f double prime. That's just f prime. And I'm going to plug in 4. And I'm going to plug in 2. And I'm going to subtract. I mean, you have to do a little bit of arithmetic, but that's it. It's really just a fundamental theorem and subtraction. F of 4, what did they tell us? That was 1.7. If you go back to the table, I'm sorry, f prime of 4. F prime of 2 was 2. And so it's negative 0.3. That's it. That's the whole problem. That's 2 points. There's no way that you should have got that one wrong. That is a basic fundamental theorem question. Easy data was given. You just had to recognize it and do a little bit of arithmetic. Actually, you didn't really need to do the arithmetic. If you would have stopped right here, that's a correct answer. You would have got full credit. Let's move on to part D. Part D. Here's a little bit of a clue when you're taking the AP exam. If you're looking at a free response question that has a limit, and what I'm about to say is not universally true, but playing the odds here, more than likely this is going to be true. If you're dealing with a limit in a free response question, it's a L'Hopital's question. Okay, you just got to recognize it and do it. Okay, the clues are there, but this is what you're supposed to do. You're supposed to do L'Hopital's rule. Okay, let me show you how. Okay, so I'm going to write this a little bit larger so I can see it more clearly. So minus 20e to the x over 0.5 times f of x minus 10. So if I try to do direct substitution, okay, if I plug in 0, I get f of 0, which f of 0 was 20. They told us that. I was going to say I have to scroll back up because I don't remember. So f of 0 is 20. E to the 0 is 1, so this becomes 20 minus 20. If I plug 0 into the bottom, f of 0 is 20. Half of 20 is 10, so I get 10 minus 10. So this is that 0 over 0. So that means it's an indeterminate form. Don't call it 0. Don't call it it does not exist. We have more work to do. And L'Hopital's rule is going to help you out of this one here. So if you apply L'Hopital's rule like this, what do we get? So I got to take the derivative, and the derivative of f will be f prime. The derivative of 20e to the x is just 20e to the x. In the denominator, I get 0.5 times f prime of x. And the derivative of 10 is 0. Okay, so this is what I get. Let's do some direct substitution. I get f prime of 0 minus, well, e to the 0 again is still just 1. So 1 times 20 is 20. And times 0.5 times f prime of 0. I don't remember what f prime of 0 is, so I'm going to have to scroll all the way back up here. And look, f prime of 0 is 4. Okay, sorry, this is a little bit slow. I should have looked it up ahead of time. But 4 minus 20 over half of 4, which is 2. So it's negative 16 over. Again, you don't have to do any simplifying. You can stop at any point. So I believe it's a 2-point question. 1 point for doing L'Hopital's rule. 1 point for the answer. It's not a hard question, ladies and gentlemen. You could have done this. I know you could have done this. You've seen this. What it takes is to be a little bit more calm during the quiz, to think a little bit more clearly, to not panic, to work through things systematically the way I've taught you. I know you can do this. Okay? So let's stop being so nervous, and let's go into this with a clear mind and just go through the steps the way I've been demonstrating. And if some of the stuff I'm explaining to you, you don't quite remember, okay, go through your notes, go look at some examples, send me an email, give me some more, looking for some practice questions, whatever it takes. Okay. I know you can handle this. So let's slow down a little bit. Let's think clearly, and let's not make the silly mistakes. Let's improve our conceptual understanding. Let's recognize the fundamental theorem when it's going to be there, and let's do the things that we've been taught. Let's do the things we know how to do. I know you can, so let's perform. Go study.